2 squared, 7 cubed, and 1,000 to the power of 1,001 have been solvable and traumatizing kids for a very long time. However, what happens if this exponent was not a natural number? What happens if it wasn't? This was a question that scientists asked in the 1930s. What happens if it was 2 to the power of a square, 1,000 to a random mathematical object, or 7 to the power of a matrix? But why would you ask this? Why would you want to see if this was useful? But to see if it's useful, we first need to see if it's viable, mathematically, to see if it makes sense. This was a study research field until the late 1960s, but unfortunately it dried up due to the digital revolution. And then because of this, many results were left unproven. But luckily, this research field was revived in the early 2000s, and that's where I'm currently am, trying to figure out if this is actually mathematically viable. This is so that if future engineers, scientists, and doctors find a practical use for 2 to the power of a square, the maths is already done for them. I can tell them immediately yes or no if they needed to solve a maths problem using this. So let me test if this is viable so that you can prove that it's useful. And maybe one day your kid will come home and ask you, "Mother, Father, what is 2 to the power of a square?"